In this video, I'm going to talk about the mean, variance, and standard deviation and expectation of a discrete probability distribution. Okay, if you remember from chapter 2, we discussed about finding the mean, standard deviation, variance for a frequency distribution table. So where frequency distribution table means we had like x, and then we had f, and then how did we find out the mean? We found out f times x, right? And then we enter all these things in calculator, or we did by hand. So and then we find out the summation of f of x, f times x divided by summation of f. That's what we did in the frequency distribution. But now what we want to do is we want to find out the probability distribution, the mean, standard deviation, variance of the probability distribution. Okay, so first of all, let us talk about how many decimal places we need to consider when we find out the mean, variance, standard deviation. It depends on how many decimal places are the x. If the x values are the whole number, then the mean, variance, standard deviation will be one decimal place. If the x values, or if the random variable values are in one decimal place, then these values must be two decimal places. So it should be one more decimal place than the values of x. Okay, that is one thing that we wanted to discuss here. And another thing is, when the fraction are used, they should be reduced to the lowest term. Okay, they should be reduced to the lowest term. Okay, let us define the mean of a discrete probability distribution. So the mean of a random variable x with a discrete probability distribution is given by, we denote by mu. Okay, and this is summation xi times p of xi. That is same as x1 times px1 plus x2 times px2 plus, and so on. What does that mean? That means, you remember that we had like x, and then we had px, right? This is the probability distribution, right? So if you want to find out the mean, what you do is this: you multiply this with that one, and then plus multiply this with that value, plus multiply this with that value, and then so on. And then if you multiply all these pairs and then add them, the value you get will be the mean of the random variable x under the discrete probability distribution. Okay, let us see an example. 3 coins are tossed. Let x denotes the number of heads. We did that already in an example, that if 3 coins are tossed, what is the sample space? It will be either head, 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 okay, head, head, tail, okay, head, tail, head, okay, tail, head, head, okay, head, tail, tail, okay, tail, head, tail, okay, tail, tail, head, okay, and then tail, tail, tail. This is the sample space. And what is the probability distribution for that? So the probability distribution is, first of all, let x denotes the number of heads. Then it will be either 0 head, that is that one, right? Or 1 head. How many? 1, 2, 3. These are the 1 head. Or 2 head means this one, this one, this one, that has 2 heads. And then 3 heads is. So these are the possible values of x, where x denotes the number of heads. Okay, let us make the probability distribution for this. We write down x and then px, right? So x means we list the values of x, 1, 2, 3, and now we find out the probability for the px. What is the probability that you get 0 head? Is there is only 1 out of 8. 1 out of 8. What is the probability of 1 head? Is 1, 2, 3 out of 8. What is the probability of 2 head? Is how many outcomes are there with 2 heads? 1, 2, 3, right? So the total is 8, so 3 out of 8, and the last one is 3 head is 1 out of 8. Now if you want to find out the mean, what you do is you multiply this with that, plus this with that, plus this with that, plus this with that. There are 2 ways. You can just multiply them and then add, or you can do, what you can do is, you can just make a table, just make another row and then multiply these 2 and then write. So x times the px, right? 0 times 1 8 is 0, 1 times 3 8 is 3 8th, 2 times 3 8 is 6 8th, and 3 times 1 8 is 3 8th, right? So what is the sum of all these? So the sum of all these, the sum of these is 3 8 plus 6 8 is 9 8 plus 3 8 is 12 8. 12 8. Okay, so mu is basically 12 over 8. That is summation of This sum is denoted by summation x times px, right? The sum of these is summation x times px is 12.8 is 1.5. I consider one decimal place because the random variable x has no decimals, right? So you need to take up to 1 decimals for the mean. So this is how you find out the mean. Let us do another example. So it says find the mean of sum of number of dots that appear on the top when 2 dice are tossed. Do you remember when 2 dice are tossed? How does the distribution look like? The probability distribution look like this, right? This is the probability distribution. Now what you want to do is you want to find out the mean. To find out the mean, what do? You need to multiply this with that, this with that, this with that, and so on. Let us do that. I don't want to write down all the outcomes. What I want to write down the table only for the probability distribution table. So x, I'm just copying from that page, okay? There is px. So there were 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? These are the sum. X denotes the sum of the dots when you roll 2 dice, and probability were 1 out of 36, 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, and then starts to decrease. 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and then 1 out of 36, right? So to find out the mean, you need to find out x times px as well. So I want to do that. X times px. X times px. Okay. So 2 out of 36. So 3 times 6 out of 36. 4 times 3, 12 out of 36, right? And then 20 out of 36. And then 30 out of 36. And then 42 out of 36. 40 out of 36. I'm multiplying x and px. 36 out of 36. 30 out of 36. 22 out of 36, and then 12 out of 36. Okay, so what we do next is we add this x times px. What is summation x times px? Is you add all these. So if you use calculator to add them, you will get 252 out of 36. 252 out of 36, which is 7. Okay, this is what you will get. So the mean mu equals to 7, and you see that, look at that, 7 is the most repeated sum, right? Because out of the 36 outcomes, 6 of the outcomes will have sum 7. All other outcomes like 8, 9, 10, 11, all these sums are repeated less, like 6, 5, 4, all these other sums are repeated less than sum 7. So it makes sense that the mean or the average of the sum will be 7. Okay, this is what you get. All right, let us do another example. That is, the following probability distribution represent the number of trips of 5 nights or more that American adults take per year. These are x. So 0, 1, 2, 3, 4. These are the number of nights people spend for the vacation. Okay, or the trips, let's say. That is, 6% do not make any trips lasting 5 nights or more. 70% take one trip lasting 5 nights or more. These are the number of trips per year that last 5 nights or more. So 6% has no trips that lasted 5 nights or more. 70% has one trip that lasted 5 nights or more. 20% has 2 trips, and so on. Find the average number of trips. You want to find out the average number of trips. You need to find out the summation or the mean of x. So what you do again is you can do x times px, right? So how much is that? This is 0 point, that is 0, right? 0.7 times 1 is 0.7. Okay, and then 2 times 0.2 is 0.4. 3 times 0.03 is 0.09. 4 times 0.01 is 0.04. If you add that, summation x times px is becoming 0.7 plus 0.4 is 1.1, right? Plus 0.09 is 1.2, 1.24, so 1.24. So this is basically the value of the mean. So the mean mu equals to 1.24. That is the average number of trips that lasted 5 nights or more over the all American. Okay, this is the average number of trips that lasted 5 nights or more. That is basically average. Okay, all right. So this is for the mean. Now how do we find out the variance? To find out the variance, it is similar to the mean, but what we do is we need to find out x squared times px. So we need to find out x times px as well. Why? Because we need to find out mean. So first find out mean and also find out x squared times px. So we will need one more row and then we need to find out that sum. Okay, and then subtract the square of the mean from that. Okay, let us do example number 4 to find out the variance. Again, to find out the variance, you need to find out the mean as well. Okay, so let us do example number 4. It says a box contains 5 balls. The total number of balls are 5. 2 are numbered 3, 1 is numbered 4, and 2 are numbered 5. The balls are mixed and 1 is selected at random. After a ball is selected, its number is recorded. So what is x? X is basically the numbers on the ball. So numbers on the ball. B-A-L-L, ball. Okay, so how do we write the make the probability distribution table? There will be x, there will be px, right? So what are the possible values of x? Because there are 5 balls, so some balls are number 3, some balls are number 4, and some balls are number 5. So 3, 4, 5. How many balls are total? Total balls. Total number of balls is 5. That is the total number of balls, right? So 2 of them are number 3, 1 of them is number 4, and 2 of them are number 5. Now if you pick one ball, if you select one ball randomly, what is the probability that has number 3 is 2 over 5, because there are 2 balls with number 3 and total number of ball is 5. So 1 over 5 for number 4 balls and then 2 over 5 for number 3 balls. Okay, sorry, number 5 balls, because there are 2 balls that has number 5. Now we need to find out the mean and variance. That's why we need x and then so x times px, and we also need x squared times px, because the formula needs x squared times px and we need to sum them. Okay, so let us do that. So what is x times px is 6 over 5, 4 over 5, and then 10 over 5. What is the sum? So summation x times px is 6 plus 4 is 10 plus 10 is 20 over 5. That is 4, right? So the mean is 4 because the sum of x times px is 4. Now do x squared times px. How do you do that? X squared is 3 squared times px is 9 times 2 is 18 over 5, right? 4 squared times 1 over 5 will be 16 over 5, and 5 squared times 2 over 5 will be, so that will be 25 times 2 is 50 over 5. So what is the sum of these? Summation of x squared times px. So that will be 18 plus 16 is 34 plus 50 is 84 over 5. That is the value of x squared times px. Okay, so how much is that? Is that 16.8? That's right, 16.8. Now how do you find out the variance? The notation is sigma square, the same as the population variance there. So sigma square is summation of x squared times px, right, minus mu square. So how much is that? Summation of x squared times px is 16.8 minus 4 square, right? How much is that? That is 16.8 minus 16, that is 0.8. That is variance. How about the standard deviation? Standard deviation is the square root of variance. So sigma is square root of 0.8. So how much is that? 0.8944. 0.8944. That is the standard deviation. Okay. Okay, let us look example 5. Example 5 is similar to example 4, even it is easier because x and px are given. So how do you do this problem is to find out the mean and variance and standard deviation. You need to find out x times px, find out the sum here, okay, and then also find out x squared times px, x squared times px, find out for each of those x squared times px, and then find out the summation here, okay. So then find out the summation, and then you just sigma square equals to summation x square times px minus mu square, because this will be the mu, the summation of x times px will be the mu, and just whatever value you get is the final answer. So you do by yourself. I want to do example number 6 here. Okay, so let us do example number 6. The number of students using the MATLAB per day is found in the distribution below. Find the mean, variance and standard deviation for the probability distribution. So you can do that exactly the same way. Okay, what is the probability that fewer than 8 or more than 12 use the lab in a given day? Alright, so let us see this example. I will do both by hand and by using calculator. So using the calculator is exactly same as how you did in chapter 2. Okay, so what it says is the number of students using the MATLAB per day is found in the distribution below. Find the mean, variance and standard deviation for this probability distribution. What is the probability that fewer than 8 or more than 12 use the lab in given day? So to find out this is x, px is given. So to find out the mean, what do? You do x times px, 6 times 0.15, 8 times 0.3, and so on, right? If you add that, you get 9.4. That is the sum, that is mu. So mu is 9.4. Okay, that is basically the mu. So mu is 9.4. Now to find out the variance or the standard deviation, you need to find out x squared times px. How do you do that? You do 6 squared times 0.15, 8 squared times 0.3, and you write here 10 squared times 0.35, 12 squared times 0.1, and then right here, and so on. If you add these, you get 93.6. Okay, now to find out the variance, the formula is summation of this value minus square of that. That's what we did. 93.6 minus 9.4 square will be 5.24. That is the variance. Okay, now to find out the standard deviation, SD is square root of the variance, that you get 2.289. Also, let me answer the question that it says fewer than 8 or more than 12. What is the probability that fewer than 8? That means this one, right? So probability of fewer than 8 or greater or equals to 12 will be 6. So is fewer than 8, the probability is 0.15, right? And then plus, because it says or, greater than 12, right? Greater than 12 means 14, that means the probability is 0.1. So if you add that, you will get 0.25. Now what I want to do here is I want to show you how to find out this using the calculator. It is exactly the same method as we did in chapter 2. How do you do that? Is go to the calculator there. Okay, let us do exactly the same problem in the calculator. Okay, so how do you do that? First is again, so if you remember that from chapter 2, how do you find out the mean and standard deviation? So what you do is go to the stat and there is edit, right? Hit enter. So in L1 you enter x values, so you enter 6, right, 8, 10, right, 12, and then 14. That's the L1, right? Now what you do is you want to enter that on L2 is px values. So 0.15 enter, 0.3 enter, 0.35 enter, 0.1 enter, and 0.1 again, right? So this is what, so we entered x in L1 and then px in L2. So what you do after that is basically go to the stat, okay, and then calc. How do you get the calc? Is the right arrow. Go to the calc and there is one variable status, okay, hit enter. That's what you get. So list, meaning the value of x are in L1, frequency list. So it is not, nothing is picked. So we need to pick the frequency list L2. Where is L2 there? L2 is there, right? Just above 2 is L2. So you do second and then so let me go down a little bit. Let me go to the frequency list and you do second and then 2. is L2, okay, and then go down and hit enter. That gives you the X bar, okay. What is our X bar value? X bar is the mean, right? So you got the mean is 9.4. That's what the mean is, right? And what is the summation x square? That is x square times px, basically, in our case. That is 93.6. That's what you get. And then sigma x is 2.289. You see that? Sigma x is basically, sigma is the standard deviation, 2.289. And you find the sigma square is 5.24. This is how you do it. This is the exact method you did in chapter 2 to find out the mean or standard deviation, right? So again, what you do, you go to the stat and then edit, hit enter, and on L1 you enter x values. In L2 we used to enter f, the frequencies, but here we don't have frequency, we have the probability, so you enter the probability here, okay, on the L2. And then after you finish entering those values, you go to stat, calc, and then one variable status. Now you hit enter there, and then you pick list is in x values and frequency list L2. So you can enter in L3, L4, anything, but you need to pick those column here, column name here, okay, and then hit enter and go to the next, and then hit enter. Calculate will give you all those value you need. Okay guys, all right, so this is how you find out the mean and standard deviation using the calculator. Thank you.